In this video, we will evaluate trigonometric functions at special angles. We will also be finding the angles that will give specific trig values. We are going to need these 6 facts to be able to do this, in addition to a little bit of knowledge about the unit circle. So make sure you have these facts back in the front of your brain. Remember that if I hand you a blank sheet of paper and tell you to write down the 6 key trig values, you should be able to generate this table. Starting with the yellow ones, which you definitely have to memorize. You definitely have to memorize these 3. But then, of course, the white ones come easily from the yellow ones. Alright, because the cosine of pi over 4 is the same as the sine. And the sine and cosine of pi over 3 are just the reverse of the sine and cosine of pi over 6. So if you memorize these 2, just switch them and you'll have pi over 3. Anyway, I'm going to assume that you have these 6 values memorized and you have the ability to write down this table right now, or anytime you have a test. Alright, so for the rest of this video I'm just going to refer back to these. Okay, so for 13a, we need to evaluate the cosine of pi. Well, for pi, we don't need this list because pi is a quadrantal angle, meaning if you look at the unit circle, alright, pi is right on the x-axis, okay? So here's pi over here. Alright, here's pi is in this position. So when we are dealing with a quadrantal angle right on the quadrant, what we need are the coordinates instead. So, for example, here the coordinates are 1, 0 because I'm to the right. Here the coordinates are 0, 1. This is -1, 0. And this is 0, -1. Now the cosine is always the x value on the unit circle. Okay, so that's a cosine, that's a cosine, that's a cosine, and that's a cosine. So specifically, we are being asked what's the cosine at pi? Well, at pi, it's -1. So that's it. Alright, but if we're dealing with this though, now moving on to part B, the sine of 3 pi over 2. Is that a quadrantal angle? You know what, that's another quadrantal angle, isn't it? So, quadrantal angles rock. Because 3 pi over 2 is down here at the bottom. This is 3 pi over 2. Alright, it's this position right here. And again, the coordinates are 0, -1. Now the sine function on the unit circle is a y value. So this is a sine function. This is a sine value. This is a sine value, and this is a sine value. Alright, but for this particular problem, we wanted the sine value at 3 pi over 2. So that is -1. Okay, easy peasy lemon squeezy. Now this one is not a quadrantal angle, so I can't just draw a unit circle and just get the values off a coordinate. So this is when you need this chart. Okay, now the reference angle is where you begin. So cosine of any random angle is going to equal the cosine of the reference angle. Alright, the reference angle is pi over 6. When you have these special angles, pi over 6, pi over 3, pi over 4, and you see some multiple of that, the reference angle is just going to be what you would have if you took out the multiple. So these will be the same, except maybe I need a negative sign on here, maybe I don't. Alright, so to figure out whether or not we need a negative sign, we will look at the quadrant. But first of all, what is the cosine of pi over 6? Well, that's one of the ones we're supposed to memorize. So the cosine of pi over 6 is radical 3 over 2. Okay, so that means we have radical 3 over 2. But again, maybe this should be negative though. I'm leaving a little space for a negative sign if I need it. So let's look at our unit circle and figure out if we need to make this negative or not. So here's pi. Alright, pi is the upper hemisphere. We are dealing with a reference angle of pi over 6. So I'm going to draw a bunch of pi over 6's. So to do that, first I start with pi over 2's, alright, half pi's, and then I split them into 3 pieces each. Okay, so I will split this in this way. Okay, see how I have 3 pieces now? I'll do the same thing again over here. So now I've divided my top hemisphere into 6 pieces. So I've got pi over 6 happening. So I need to go negative 5 pi over 6. That means 5 pi over 6 clockwise. So here I go. Negative 1, 2, 3, 4, 5. So this is a picture of negative 5 pi over 6. Okay, so the terminal side here is in the third quadrant. So cosine is negative in the third quadrant, which tells me that I will in fact need a negative sign on this. Okay, but that's it. So the value of the cosine of negative 5 pi over 6 is negative radical 3 over 2. Let's see if the calculator knows this or not, because it seems like they said that they were going to let you use a calculator. So, you know, if you're on YouTube or something, you don't know who I'm talking about. But so the point is, maybe you're allowed to use a calculator. So if you are, let's just see what would happen. So if I try to evaluate the cosine of negative 5 pi over 6, okay, that would be the cosine of negative 5 pi over 6. Okay, it gives me this decimal, alright, and okay, I try to toggle it. It's just giving me the decimal. So it's not giving me, oh, and not only that, but I'm sorry, because we're in degree mode. Maybe if I switch to radian mode. Alright, it's a valuable lesson for you guys. See how the calculator says degrees? Because I'm like, this is not right, because this is supposed to be negative, and this is not even a negative number. I think it's because I'm in degree mode. So if I hit the mode button, switch to radians, okay, now it says rad. Now I'm in radian mode. Okay, still in radian mode. So let me go back and see if that makes a difference. So I'm going to execute this again. Oh, look, and now it works. Negative radical 3 over 2, which is what we got. So, moral of the story there. If you're going to do this and you are allowed to use a calculator, which I think you are if you're like one of my students, you have to make sure you're in radian mode if you're going to try to use your calculator to do this. Of course, you should know how to do it without a calculator, because that's what we did on the last test, and this is sort of a review concept. Okay, let's do number 14 as well. Find the values for which the equation is true. So we're finding at what angles will cosine equal 1. Well, with answers like 1 and negative 1, we must be talking about quadrantal angles, okay, landing right on the quadrant. So let's remember the unit circle and how it works. Okay, like I just said a moment ago, the coordinates are, you have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Cosine. Cosine is an x value on the unit circle. So that's cosine, that's a cosine, that's a cosine, and that is a cosine. So they're saying, hey, which angle is going to give me a cosine of 1? Alright, well, there's 1 right there. Okay, so it's got to be this. So that's, you could either call this 0 or you could call it 2 pi. Okay, so either way. So you could say 0 or you could say 2 pi. Now that I think about it, the directions did not limit and say, you know, between 0 and 2 pi or anything like that. They just left it wide open. So if assuming that that was on purpose, then we need to put some variables on here. And we would say 2 pi n, where n is an integer. Okay, so if n is 1, then that's just 2 pi. But if n is 2, then it becomes 4 pi and 6 pi and 8 pi. All of those would just take us back to the same spot. So assuming that it was not an accident that they didn't specify between 0 and 2 pi, then you have to do this. Okay, look at part B here. I don't feel like drawing a whole new picture. Just look back at the previous picture because it's the same info. Where is the cosine equal to negative 1? Well, cosine is equal to negative 1 over here. Let's see, can I get rid of this? Dink. We're talking about over here, okay? And it's cosine is equal to negative 1 here at pi. Alright, but then I can get to pi again and again by going all the way around. So I can say pi plus 2 pi n, where n is an integer. Alright, and let's look at this last one. This is number 14C. Where is sine of theta equal to 0? So one more time, we could look at a unit circle. Okay, so like we did on the other problems, here we have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Now the sine function is a y value on the unit circle, so we're talking about this and this and this and this. Those are the y values. But we want to know where sine is 0. So sine is 0 here and here. Okay? So it's right here at 0 and then at pi. Okay, but it's going to keep going around and around. Every time we add another pi, we're going to be back to 0 again. Okay, so we can say theta is equal to pi n, where n is an integer. Okay, so you can see how that would work out. So if n is 1, then that's going to give us pi, and we'll have 0. If n is 2, then that would be 2 pi, and that would put us here, and that would be 0. Alright, but if n is 3, then that would be 3 pi, which would put us back to here again. Alright, and even integers can be negative, so we could go negative. So if n was negative 1, that would be negative pi. That would be here, and that would still be 0. Okay, so that is how you could do it. Now, real quick, it just occurred to me, alright, I kept doing this all during the unit circle, but in the last unit, well, the first half of the unit, we practiced the unit circle. But in this unit, we've been working more with graphs. So when we did number 13, for example, I think I was supposed to encourage you to look at the graph of cosine instead of the unit circle. So just really briefly, if you look at the cosine of pi, okay, let me find my graph of cosine. Okay, here's what the graph of cosine looks like. Alright, cosine theta. And here's pi right here, and at pi we are at -1. Okay, so that's another way to think about the cosine at pi as -1 instead of the unit circle thing. Okay, similarly, if you wanted to evaluate the sine of 3 pi over 2, instead of using the unit circle like we did on the previous unit, let's find this on the sine graph. So you could easily graph the sine of an angle. Here's your traditional 2 pi, 1 period of this thing, and you see 3 pi over 2 falls right here, and the value here is -1. So that's another way to look at that. Now, when you get into the pi over 6's and -5 pi over 6, looking at that on a graph, to me, is a lot more complicated than simply using the unit circle. So I would still do this one the way that I did it. But again, real quick, looking at number 14, if I wanted to talk about what angle gives me a cosine value of 1, we could look at the graph. And so where is it going to be equal to 1, you say? Well, it's going to be equal to 1 here at the top. Okay, so that's 0. And then it'll be here again at 2 pi. So you can see that it's only going to be multiples of 2 pi. So it's like 0, and then 2 pi, and then 4 pi. Okay, so that's even multiples of pi. So that gives me a second way to answer this question. Instead of saying 2 pi n, where n is an integer, I could say pi n, where n is an even integer. Alright, these two things are equivalent, but looking at the graph, it's easier to see it as, 0 pi, 2 pi, 4 pi, and I could continue. And if I went to the left, -2 pi, -4 pi, -6 pi, it's all even multiples of pi, even integers. Okay, so I think I was supposed to encourage you to look at the graphs of these things. And it would have been the same thing with cosine of -1. Okay, where is the cosine equal to -1? Well, the cosine's equal to -1 down here and here. Okay, so that's 1 pi, 3 pi. These are odd multiples of pi. So another way of answering this question would have been to say pi n, where n is an odd integer. And this blue way of saying it is more obvious when you're looking at the graph, which I think is what we were supposed to kind of do. Alright, and one more time, looking at it graphically, where is the sine function equal to 0? Well, here's my sine function, and it's equal to 0 here at 0, and then pi, and then 2 pi, and then 3 pi, and then 4 pi. So 0, 1, 2, 3, 4. It's hitting every single multiple of pi. And it would be the same thing in the negative direction. Negative 1 pi and negative 2 pi is 0 at all the pi's. So, so pi n, where n is an integer. So that's the same thing that we got by looking at the unit circle, is the same conclusion, the same way of thinking of it when we look at the graph. Okay, this video is long, so I'm going to wrap it up. Here endeth the lesson.